Welcome to ZoomInData, your go-to channel for in-depth data engineering, analytics, and modern cloud technology interview preparation. In this video, we dive deep into the top 25 notebooks in Microsoft Fabric interview questions for 2025. Perfect for data engineers, data scientists, and anyone preparing for Fabric Lakehouse, data engineering, or data science roles. We cover core concepts, languages, Spark integration, OneLake access, collaboration, Git version control, pipelines, parameterization, machine learning, performance, security, and best practices, all explained in clear, interview-ready technical language to help you confidently ace your next interview. 1. What are notebooks in Microsoft Fabric? Notebooks in Microsoft Fabric are interactive, web-based environments for developing Apache Spark jobs, data exploration, transformations, and machine learning experiments. They provide a collaborative interface with code cells, markdown support, rich visualizations, and integration with Lakehouse artifacts for end-to-end workflows. Built on managed Spark clusters, notebooks support exploratory analysis, ETL processes, and production-ready scripting within the unified platform. Enhanced with Copilot for code generation, inline completions, and AI-assisted authoring to accelerate development. 2. What languages are supported in Fabric notebooks? Primary support includes PySpark, Python, Spark, Scala, Spark SQL, and Spark R for distributed processing. Magic commands enable cell-level switching, such as %%SQL for TSQL or %PySpark for Python-specific execution. Pure Python notebooks, without Spark, are available for lightweight workloads using libraries like Pandas and Polars. IntelliSense and Pylance provide advanced code completion, with varying maturity across languages. 3. How do notebooks integrate with Spark? Notebooks run on fully managed Apache Spark clusters with starter pools for rapid session startup and autoscaling. They leverage Spark data frames, RDDs, and structured streaming for distributed computation and real-time processing. Custom session configuration via %configure magic command tunes driver, executor resources and Spark properties. High concurrency mode enables shared sessions across multiple notebooks for efficient resource utilization. 4. How do notebooks access OneLake data? Direct attachment to Lakehouses provides seamless access to Delta tables and files via Lakehouse Explorer. Relative or ABFS paths enable reading and writing to OneLake without duplication, supporting shortcuts for external data. Delta Lake operations like merge, optimize, and time travel ensure ACID-compliant interactions. Outputs persist as Delta tables, immediately queryable across Fabric workloads. 5. How do notebooks support collaborative development? Real-time co-authoring allows multiple users to edit the same notebook simultaneously with presence indicators. Cell-level commenting facilitates discussions and feedback within the notebook interface. Workspace-level sharing via RBAC controls access for team collaboration. Integration with Git enables branching, pull requests, and code reviews for structured teamwork. 6. How do notebooks manage execution environments? Custom environments attach reusable library sets, including PyPI, CRAN, or custom wheels, eggs. Session configuration via %configure customizes pools, vcores, and dynamic allocation. Resource Monitor pane tracks real-time usage for Python and Spark sessions. Autoscale and bursting optimize compute based on workload demands. 7. How do notebooks support version control? Native Git integration with Azure DevOps or GitHub tracks notebook definitions, excluding cell outputs. Branching and pull requests enable isolated development and code reviews. Sync operations preserve metadata like default Lakehouse and attached environments. Deployment pipelines promote versions across dev, test, prod workspaces. 8. How do notebooks integrate with pipelines? Notebook activity in data pipelines orchestrates execution with parameter passing and dependencies. Supports runtime as user, service principal, or workspace identity for secure production runs. Integration enables hybrid workflows combining notebooks with copy, dataflow, or script activities. Monitoring aggregates pipeline and notebook run metrics in a unified hub. 9. How do notebooks support parameterization? Toggle parameter cell marks variables for override during pipeline or scheduled execution. Base parameters in pipeline activities pass values using expressions or variable library. Supports simple types, int, float, bool, string, complex types via JSON serialization. Variable library centralizes reusable values across notebooks and pipelines. 10. How do notebooks handle error management? Cell-level execution isolates errors, allowing independent reruns without restarting sessions. Detailed stack traces and runtime logs aid troubleshooting in the output pane. Try except blocks and custom logging capture exceptions for robust workflows. Monitoring Hub provides alerts and historical run diagnostics. 11. How do notebooks support data exploration? Built-in visualizations like display and Matplotlib render data frames interactively. Lakehouse Explorer enables drag and drop loading of tables, files into code cells. Profiling tools and query diagnostics reveal data distributions and anomalies. Semantic Link connects to Power BI models for measure evaluation and lineage. 12. How do notebooks integrate with Power BI? Delta tables written via notebooks support direct lake mode for low-latency semantic models. Semantic Link SemPy libraries query Power BI datasets programmatically within notebooks. Shared OneLake access eliminates duplication for unified reporting. Model outputs enable batch scoring directly consumable in Power BI reports. 13. How do notebooks support scheduling? Spark job definitions provide parameterized, recurring executions for batch workloads. Pipeline schedule triggers orchestrate notebook runs at defined intervals. Time-based or event-driven triggers integrate with broader automation flows. Run history tracks scheduled executions with rerun capabilities. 14. How do notebooks manage dependencies? Custom environments install and version libraries from PyPI, Maven, or CRAN repositories. Attached environments ensure consistent dependency sets across sessions. Git integration versions both notebooks and environment definitions. Pre-installed libraries reduce setup overhead for common workloads. 15. How do notebooks support machine learning workflows? MLflow autologging tracks experiments, parameters, metrics, and registered models. Libraries like MLlib, Synapse ML, and scikit-learn enable distributed training and inference. Predict function and batch scoring integrate with semantic models. Experiment items centralize runs for comparison and deployment. 16. How do notebooks handle large datasets? Distributed Spark processing partitions data across executors for scalable operations. Delta Lake optimizations like Z ordering and partitioning accelerate queries on massive tables. Incremental processing via change data feed handles growing volumes efficiently. Autoscaling and dynamic allocation adapt resources to dataset size. 17. How do notebooks optimize performance? Catalyst Optimizer and Adaptive Query Execution tune physical plans dynamically. Caching, persist, reuses intermediate data frames in memory or disk. Native Execution Engine and VOrder enhance read, write efficiency. Monitoring and advisor tools identify bottlenecks for tuning. 18. How do notebooks support automation? Pipeline activities trigger parameterized notebook runs in orchestrated workflows. REST APIs enable programmatic creation, execution, and management. Spark job definitions automate recurring batch jobs. CD via Git and deployment pipelines streamline production releases. 19. How do notebooks manage user permissions? Workspace RBAC, admin, member, contributor, viewer, controls notebook access. Item level manage permissions override workspace defaults for granular control. OneLake security propagates row, column restrictions to notebook queries. Service principal execution in pipelines enhances secure automation. 20. How do notebooks support debugging? Cell isolation allows targeted execution and output inspection. Inline error highlighting and stack traces pinpoint issues. Resource monitor visualizes executor usage and bottlenecks. Logging via print, display and custom statements aids diagnostics. 21. How do notebooks handle code reuse? Modular cells and functions enable internal reuse within notebooks. Custom libraries in environments package reusable code. Git branching supports shared component development. Import from OneLake files or external repos promotes modularity. 22. How do notebooks manage secrets and credentials? Azure Key Vault integration retrieves secrets securely in code. Managed identities authenticate to services without exposing credentials. Pipeline connection properties support service principal execution. Workspace secrets via variable library, secure variables, prevent hardcoding. 23. How do notebooks integrate with Git? Direct workspace connection to Azure DevOps or GitHub for bidirectional sync. JSON-based definitions version code, metadata, and attachments, excluding outputs. Branch out creates isolated workspaces for feature development. Pull requests and deployment rules ensure governed promotions. 24. How do notebooks scale for enterprise usage? Capacity autoscaling and high concurrency support multi-user environments. Git, CI, CD and deployment pipelines enable governed, multi-stage releases. Custom pulls and bursting handle peak enterprise workloads. Unified monitoring and governance integrate with Purview and RBAC. 25. What are best practices for using notebooks? Adopt modular design with parameterized cells and reusable environments for maintainability. Leverage Git branching, pull requests, and deployment pipelines for collaboration and ARM. Optimize with caching, partitioning, and incremental patterns. Monitor resource usage regularly. Secure with managed identities, Key Vault, and OneLake RLS. Avoid hard-coding secrets. Thank you for watching. If this video helps you prepare for your Microsoft Fabric interview, please give it a thumbs up and share it with your network. Don't forget to subscribe to ZoomInData and hit the bell icon for more in-depth data engineering, analytics, and cloud technology interview prep videos every week. Drop your questions or topic requests in the comments. Let's zoom in on your success together.